Hello world! Welcome back to another TryHackMe challenge video. In this video, we're going to be solving the Carnage room. Let's dive in. So this room is going to be focusing on network forensics. And what I mean by network forensics is that when someone is connecting to the internet or a network or whatever, there are packets that are transmitted across the wire essentially, right? And these packets hold data that we can actually use software to capture and read and parse that data. The most widely known tool for this is Wireshark, and that's what we're actually going to be using to go through this room with. And Wireshark is just the most popular and widely known and utilized software that allows you to capture and parse network traffic and read it. So let's go ahead and start with the scenario and see what we're dealing with. Eric Fisher from the purchasing department at Bartel Ltd has received an email from a known contact with a Word document attachment. Upon opening the document, he accidentally clicked on Enable Content. The SOC, which stands for Security Operations Center, department immediately received an alert from the endpoint agent that Eric's workstation was making suspicious connections outbound. The PCAP, which is stands for packet capture, which are the files that Wireshark reads when you're capturing network data in order to parse it out. The PCAP was retrieved from the network sensor and handed to you for analysis. Our task is to investigate the packet capture and uncover the malicious activities. Okay, so let's go ahead and complete that task since we've already, read through the scenario. And let's go ahead and go on to task 2, which is where our actual challenge starts. Are you ready for the journey? Please load the PCAP file in your analysis folder on the desktop into Wireshark to answer the questions below. Alright, so let's go ahead and launch up Wireshark. Okay, now that Wireshark is loaded, we can actually open our file, which it said it was on our desktop, analysis. Here it is, our .pcat file, right? Because that's the type of file that Wireshark reads. And let's go ahead and maximize the screen. Maximize the window, I mean. Okay, so now you'll see you have a bunch of data here to look at, right? So up in this top portion that kind of looks like an Excel spreadsheet, right? You're gonna see, your columns, and you can actually customize what kind of data you see in these columns and add columns easily just by right-clicking and on something that you're looking at, maybe down here, and then, kind of adding that to apply as column like that. Wireshark is very versatile in this way, and basically you can just parse and read any data that is captured on the line and display it out in a format that's readable, essentially, okay? So this bottom section down here is our drop downs where it goes through each layer of basically the OSI model for that packet, right? So each packet's gonna contain, you're gonna start with your physical and then your data link and then your network and then, your transport, and then you're gonna go, your session, presentation, application, right? So that all depends on what type of protocol is being utilized in the packet itself. So, and then down here, you're going to see raw data output, right? Which we can actually go ahead and minimize that since we won't be using that too much for this. We're going to be mainly using this section up here and this section down here for the majority of these challenges. So, let's go ahead and get started with the first one. What was the date and time for the first HTTP connection to the malicious IP? All right, so as you'll notice, there's a time right here, and you'll see that that's not a time that we can really make out, right? And the answer format shows a specific format that we need to use. And so what we can do is we can go view time display format, and we can actually select this UTC date and time of day down here, because that actually, if you look in the example that it has out in the parentheses over here, that actually has the proper format that we need to put this in. So we just got to select that. Now we're just going to type in HTTP up here, because our filter is what we're going to be using to basically parse our data results, right? We put in a filter to allow us to narrow down the packets that we actually want to be looking at, right? And since we know that our question is asking for HTTP packets, we can simply do HTTP. And there you go. We have a bunch of HTTP packets. Now, we want the first connection, right? And so the time is in order from earliest to latest. So we just need this first packet right here. So our answer for the first question will be 2021-09-24 16:44:38. It's probably going to be 39 since we might need to round up. Nope, that's right. Okay, so let's move on to the next question. What is the name of the zip file that was downloaded? Well, if we look out to the side here, we can actually see a zip file right here, right? Since this is an HTTP request, we know that this GET request is actually requesting from whatever website it's grabbing it from or domain it's grabbing from. It's actually requesting from this incident-consequator directory within that web domain. It's basically getting a download of documents.zip for us, right? Or, well, when this packet capture was run on the network, that's what was taking place on the host machine. So we're just going to type in documents.zip. And we got it. All right. What was the domain hosting the malicious zip file? So all we got to do for this is just go to our little info drop downs down here, and we're going to basically expand this hypertext transfer protocol drop down, right? And we're going to notice that there's a host domain right here, right? So this domain, this host HTTP header, right, just represents whatever domain is actually hosting this request. Where when we navigate, whoever the host was navigating to this page on the internet, this host is who is providing this documents.zip file. So we're just going to type in eternetful.com, and there we go. Next question. Without downloading the file, what is the name of the file in the zip file? Okay, so what can we do here? Well, what we can do is we can simply just do right click, and what's cool is we can actually follow these different streams, right? And what these different streams represent is basically the conversations to and from, or between the source and the destination, right? And so if we select HTTP stream, and TCP stream would have worked for this too, we can actually see the contents of our response, right? So when we set the GET request out, what we get back is an OK response from HTTP, right? That means that the connection was successful and the TCP handshake was successful. And in the contents, we have our actual zip file, right? Because in our response, that's what we're actually downloading, is that zip file. So if we just look at the source code of our zip file, right, we'll notice that there's a chart.whatever.xls, right? And that is going to be the name of our file that's within our zip file. Our next question asks, what is the name of the web server of the malicious IP from which the zip file was downloaded? Okay, so all we got to do is take a look at our HTTP headers from the response, right? And we'll notice that there's actually a server header right here, and right next to it is Lightspeed. And that is going to be the web server from which our zip file came from. Now it's asking, what is the version of the web server from the previous question? Now, we can tell by the answer format, right, that it should be pretty easy to pick out. And you'll notice that there's one up here, right here, this X powered by header that actually has exactly the format we're looking for the answer, right? And X powered by is just simply what framework is powering this essentially website, right? Or this domain. It's basically what the backend is using. So we're going ahead and copy that over and paste that in. Submit that. All right. Malicious files were downloaded to the victim host from multiple domains. What were the 3 domains involved with this activity? Okay, so this one's going to be a little more complicated than the others. So what we're going to do, we're going to go ahead and clear out our filter so we can reset it. What we're going to do is we're going to come up here and we're going to go to statistics and we're going to go to conversations. And this is basically going to show us all the conversations for each of our major protocols, right? So we're going to click on TCP because that's really what we want to look at, right? Is what TCP ports are having the most conversations. And then we're going to sort by the packets, right? Because we want to see which conversations are sending the most packets across the line, right? Since we know that we're dealing with a victim host and we're looking for malicious domains, we should assume that the domains are in constant contact with the host, assuming that the host was successfully infected by those domains or successfully victimized by those domains, right? In order for the target machine to actually communicate with the, malicious machine, right? We actually need to look for different HTTP protocols that could be used. And if you notice these top 3 ones up here, 63557 is an ephemeral port, so we're not too concerned with that. 443 is HTTPS, 8080 and 80 are both HTTP. So these malicious domains could be any of those HTTP ports. So we need to actually tailor our filter that we want to narrow down what these potential domains could be, because there could be several just normal domains that aren't malicious at all, right, in our search results. So we're just trying to narrow down which domains could be the malicious domains, and we have the actual format for each one. So we just need to match domains with the answer format, and we'll find the right ones we want. So let's go ahead and do one more thing. Since we can typically see domains in the HTTP responses for our packets, we don't have to worry about doing anything special for ports 80 and 8080, since they're in plain text. But 443 is encrypted, so if you want to be able to see everything that we want to, and HTTPS also is usually encrypted via TLS, we actually need to drill down into a TLS packet and add the server name as a column, or apply the server name as a column to our data output. That way it's easier to find what malicious domains we're looking for. So that being said, so we need to filter by TCP port equals 443. Okay. Now we need to look for one of these client hellos, right? And what we're going to do is we're going to drill down into our client hello, and we're going to look for the server name extension right here. Okay? So if we drill down in there, we can actually find the server name right here. So we're going to go ahead and right click, apply as column. And if you'll notice, anytime we have if we have an IP that's or domain that's associated with 443 that's encrypted, and we can't see the server name, we will now be able to see that server name if there's one existing. So now that we have that, we can go ahead and formulate our filter to find the malicious domains. So we know that we already have 443, right? So we want to do or tcp.port equals 80, or tcp.port equals 8080. Now the reason I'm putting these in parentheses is because we want one more thing, right? And that's because you see how server name could be empty? Well, we don't really want results where the server name is empty when we're dealing with these ports, right? So what we're gonna do is we're gonna do tls.handshake. In fact, we don't even need to do that. Honestly, we can just come down here and say apply as filter and select it. And we need to do a little modification because it kind of messed it up a little bit since I already had the and there. But instead of saying antls handshake.extension _ server _ name equal something, right? We want to say not equal to empty string. And that didn't work because, we need to get rid of that parenthesis. There we go. Okay, so now we got a bunch of server names to go through, right? So let's go ahead and sort these alphabetically. Going ascending. Let's go ahead and start scrolling through these and see if we can't find 3 domains that kind of match the formats down here. So if we scroll through, we'll get, let's see. It looks like our first answer is right here, findjewels.com.au. Yeah, let's just kind of take note of that since we kind of need to see the the patterns in order to figure out what the answers are. All right. And the next one will be, let's see. Looks like that newamerical.com follows that last one. So let's go ahead and add that one in. Okay, and then our last one. It looks like .com may be our last one we need. All right, let's take these. Let's paste them in. All right. Didn't need a hint for that one. Which certificate authority issued the SSL certificate to the first domain from the previous question? Okay, so we're going to go back up to our findjewels.com packet. And then we're going to, let's go ahead and minimize this transport layer. And then all we're going to do is follow the TCP stream for that packet. Kind of like what we did before, except we follow the HTTP string, but because this is a HTTPS packet, right, or a TLS packet, we're not going to be able to follow the HTTP stream because it's not in plain text, right? It's encrypted. So, for those of you who don't know, GoDaddy is a certificate authority, so that should be what our SSL certificate is issued through. So we'll go ahead and do GoDaddy. See right there, GoDaddy, and then, yep, GoDaddy root certificate authority. Okay, so that should be our answer. All right, next question. What are the 2 IP addresses of the Cobalt Strike servers? Use VirusTotal, the community tab, to confirm if IPs are identified as Cobalt Strike C2 servers. And C2 servers are just command and control servers. They're what, basically, if your machine gets infected by like a botnet or something like that, it's basically what your machine calls back to and to communicate with the malicious IP address, right? That's the server that essentially is attacking your machine, or at least maintaining persistence with your machine to gather information or do whatever else it's going to do to your machine, assuming that you're infected. How are we going to tackle this? Well, I guess we first need to figure out what ports or IP addresses Cobalt Strike servers are associated with, right? So what we can do is we can just Google the MITRE attack framework, and we're going to look for Cobalt Strike. This should be it right here. And basically, the MITRE attack framework is just a framework that MITRE developed that shows you how adversaries can attack machines, right? Or attack different things. And it's got loads of different techniques and methodologies that explain how and what can use what ports and IP addresses, etc., to hack into a machine, right? So we're gonna scroll down here to see what kind of protocols it uses, right? Because we want to know what we need to filter by. And we're gonna see that it uses HTTP and HTTPS and DNS. So we're not going to be too concerned with DNS since that's for, name resolution. But HTTP and HTTPS, however, that's probably what we're going to be trying to find is IP addresses associated with those. Let's go ahead and close that. Let's do statistics and then conversations again. And then we're going to go to TCP again. And then we're going to sort by ports this time. Port B, right? Because we want to sort by our destination port and see what our host machine has been contacting. So we've got some 8080 addresses here. So we'll check out this 185 address here first, since that's the first one we're dealing with. So let's go ahead and go to VirusTotal, like it said. And essentially what we're going to do is we're just going to take this 185.125.204.174, right? Oop. 204.174. I think that's right. Yep. And then we're going to go ahead and search. And they said go to community and check it out. Cobalt Strike server found. All right, awesome. So we'll go ahead and leave that open in case we need it for future use, and we'll just duplicate our tab. So now that we know that that 185 address is a Cobalt Strike server, and we're looking for 2, right? Yep. So maybe the other one also starts with a 185, perhaps, right? So we just need to check now 443, since it looks like all the 8080s are the same address. 443, you have some addresses, yeah. Okay. Quite a few. Let's go ahead and check out 80 real quick. Ah, there's another 185 address. Let's see if that's also a Cobalt Strike server. A lot of times when you're looking at certain servers and stuff like that, or different like web services, they'll usually follow a similar IP format. So if you find one, another one that looks similar may actually be associated with that one. This is 185.106.96.158, I think. Go check out community. Yep, there's our other Cobalt Strike server. Okay, so that didn't take long. Luckily, the 8080 had what we wanted to begin with, because otherwise we would have been sifting through several 443 addresses to no avail, essentially, right? So let's go ahead and copy that. And we need to put this in sequential order, so we can do that. We can definitely do that. I think this one is first. Yes. Okay, let's go ahead and submit that. All right. Next question. What is the host header for the first Cobalt Strike IP address from the previous question? Okay, so all we have to do for this is come back in here. Let's go ahead and clear our filter. And we just need to do ip.addr up equal 185.106.96.158. Then we're just going to right click, and then we're just going to follow TCP stream. And let's see what we get. The host header. So here's our host header up here, so that'll be our answer. Whoops. All right. We're going through. What is the domain name for the first IP address of the Cobalt Strike server? You may use VirusTotal to confirm if it's the Cobalt Strike server. Well, first let's clear our filter. So now we need to locate the domain name for the first IP address of the Cobalt Strike server. What we can do here is we can go to View, and then Name Resolution, and then Resolve Network Addresses. And what this will do is it'll take all of our IP addresses and convert them into domain names if it knows what they are, right? Because you can tell that some of these are still IP addresses to an extent, right? Because it couldn't figure out exactly what the domain is. So now we're gonna filter by our ip.addr again. I shouldn't have cleared the filter. I should have left it, but that's fine since it saves all our previous filters. And if we look, right, you would think we were looking at server name, but because these are associated with HTTP, the server name is blank. We actually look at the destination and we'll see it says servemeter.live, and that's going to be our domain name for this question. All right. What is the domain name of the second Cobalt Strike server IP? You may use VirusTotal to confirm if it's the Cobalt Strike server. We already know it is, so there's no need to confirm it. We'll take that and, oh wait, that's right, we can't copy and paste it to here, I don't think. Yeah, we can't. Okay, so let's just take that out, and then we're gonna do 185.125.20. 5.204.174. Okay. And we're just going to do the same method we did before. We're just going to look at the destination or source. It's there too. And it's security buzz and biz and puff. All right. So security biz and puff. .com. All right. What is the domain name of the post-infection traffic? After, I think I mentioned this earlier, after a computer has been infected, it'll actually send data back to the C2 server, right? Or whatever server hacked it. And this information is usually sent, across HTTP, right? So it's sent in the form of post requests. And we saw earlier that we got a zip file through a GET request. And then going back out, we're going to be using a post request, right? Because we're posting data. Well, our victim host is posting data to the attacker's machine. So what we're going to do here is filter by HTTP again, right? Because that's where we saw the GET request before. And we're going to scroll through and see if there's any post requests, right? In fact, there's a post request right here. As we can see, let me go ahead and scroll this over so we can see it better. And we'll notice this is maldivehost.net. So that definitely sounds suspicious, doesn't it? So we're going to go ahead and type that in because that is definitely the domain name we need. Now it's asking, what are the first 11 characters that the victim host sends out to the malicious domain involved in the post-infection traffic? So we're going to look at this same post request, right? And we're going to look to the right and we're going to see what data is actually being posted, right? And we're going to see that it's this this base 64 string, right? So we just need the first 11 characters. So 1, 2, 3, 4, 5, 6, 7, 8. It's probably all the first parts. All right. And that's our answer. Okay. Next question. What was the length for the first packet sent out to the C2 server? We know that the C2 server, right, is this maldivehost.net, right? So all we're going to do is we're just going to scroll up and look to where the machine first sends a packet to the maldivehost.net. And we'll notice that our first packet to it is right here, and that's 281. And that's our correct answer. Awesome. Next question. What was the server header for the malicious domain from the previous question? So all we got to do here is just do our usual follow HTTP stream and just look for the server header. Here it is right here. All right, pretty simple. I'm glad how some of these questions just follow suit with the other questions, right? That way we're not going all over the place. The malware used an API to check for the IP address of the victim's machine. What was the date and time when the DNS query for the IP check domain occurred? And then we have our same answer format, right? We've already got it sorted by that date and time format, so we're good there. Let's close this. So typically, when there's a call out to an API, it usually has API in the URL. Now, this isn't all the time, but usually, even sometimes it'll even have it as the extension, like .api. And I think I remember earlier seeing server names that actually had API in their domain names, right? How can we look to see if API is contained in one of the packets, right? What we're going to be looking at is DNS, right? Because we want to look at DNS packets according to the question, right? So we're going to filter by DNS, and I'll go ahead and show you what that looks like. So here we have all our DNS packets, and then we want to say DNS contains API. And then we're going to get some packets that should, and then we're looking for inside the query, right? Yeah, in the query should have our API domain name. So we have api.msn.com, and then we have api.ipify.org, and it looks like that api.ipify.org is the one we're looking for, and we want the date and time. Oh, okay, so that would be whenever this first packet started, right? Our first packet for the API. So it should be this packet right here, right? Because that's going to be our API URL, right? It's not this api.msn.com. I think that's what redirects you to this api.ipify.org. We just need that date and time. Okay. Incorrect answer. Awesome. What was the domain in the DNS query from the previous question? Oh, well, we just said it, right? api.ipify.org. Great. All right, last two questions. Looks like there was some malicious spam, mouse spam, activity going on. What was the first mail from address observed in the traffic? So typically, mail traffic is going to be one of two protocols. SMTP, which stands for Simple Mail Transfer Protocol, and then POP3, which is like Post Office Protocol or something like that. I can't remember. But anyways, so SMT is usually the most popular one, so we'll start with that, right? And let's go ahead and look for that. Okay, we definitely have SMTP traffic. And then we want to look for what was the first mail from address observed. So if we actually scroll over a little bit here, and we'll scroll down, we should look for something that we can actually look for in our filter, because there's a lot of different SMTP traffic here. So we want to look for like a header that we can use to look for, like a mail from header. And I think that actually mail from is the header we're going to be using or looking at. So we keep scrolling. Yeah, here's a mail from right here. So yeah, there is packets that literally have mail from in it. So what we can do is we can do contains, and then since there's a space, we need to actually surround our mail from in quotes. That way it captures the whole string. And then what we are looking for is the first mail from address. So that is from farshin@mailfa.com. All right. How many packets were observed for the SMTP traffic? Okay, let's go ahead and clear our filter, right? Because that gives us all the data we need. The easiest way to do this is go to Statistics, Protocol Hierarchy, and then, although these aren't in their abbreviations, we know that SMTP stands for Simple Mail Transfer Protocol. So if we come down to TCP, or Transmission Control Protocol right here, we can see that there's a SMTP protocol entry right here. And if we scroll over, we'll see that it actually tells us how many packets are in our SMTP. Bring it back. Lost it. Right here. It'll tell us how many packets that Wireshark parsed as SMTP packets. And it says that there were 1,439 packets associated with the SMTP protocol. We're going to type in 1439. And that answers the last question. All right, y'all. I hope you enjoyed the video. Drop a like and subscribe if you want to support the channel, and so that we can keep producing content like this. Check out our Discord and Patreon links in the description box down below, and leave any feedback in the comment section down below. Thanks for watching, and goodbye, world.